Hello everyone, welcome to my channel. This is a video on DevOps Engineer Interview Questions Part 2. We'll start with question number 1. Question number 1 is, what is Git and why is it used? The answer is, Git is a version control system that helps you manage and keep track of changes in your code and projects. Here is why it's widely used. First is version tracking. Git allows you to record changes to your files over time. You can easily see who made the changes and what those changes were and when they happened. The second is collaboration. Multiple people can work on the same project at the same time without overwriting each other's work. Git helps merge their changes smoothly. Third is branching and merging. You can create branches to work on new features or fixes separately from the main code base. Once you are happy with your changes, you can merge them back into the main branch. Fourth is backup. Git provides a way to back up your code. If something goes wrong, you can revert to previous versions of your files. The last one is distributed system. Git is a distributed system, meaning every developer has a full copy of the entire repository on their machine. This allows for offline work and makes the collaboration easier. Second question is, explain the difference between git merge and git rebase. The answer is, for git merge, it combines the changes from one branch like a feature branch into another like the main branch by creating a new merge commit. This preserves a history of both the branches, showing a clear picture of when the branches diverged and merged. It's simple and it keeps the original context of the branches. For git rebase, it moves the entire feature branch to the tip of another branch, rewriting the commit history as if you started your work from the latest commit. This creates a cleaner, linear history without merge commits, making it easier to follow. However, it rewrites history, which can complicate things if others are working on the same branch. The third question is, what is pull request and how does it differ from a merge request? Both pull request and merge request are similar concepts used in version control system, but they are typically associated with different platforms. For a pull request, it is commonly used in GitHub. It's a request to merge changes from one branch into another, usually to propose new features or fixes. It allows team members to review the code, discuss the changes, and run tests before the merge happens. For a merge request, it is primarily used in GitLab. It serves the same purpose as a pull request, allowing teams to review and discuss proposed changes before merging. The term merge request emphasizes the action of merging changes directly. The fourth question is, describe the Git flow workflow. The first is main branches. Main or master. This branch contains the production ready code. Develop. This branch is where the latest development changes are integrated. It's the main branch for the ongoing work. Second is feature branches. When starting a new feature, create a branch of develop. Work on the feature here and once completed, merge it back into develop. Third is release branches. When ready to prepare for a new release, create a branch from develop. This branch is used for finalizing the release, fixing bugs and preparing documentation. Once ready, merge it into both main and develop. Fourth is hotfix branches. If urgent fixes are needed in production, create a hotfix branch from the main. After the fix, merge it back into both main and develop. Fifth question is, how do you handle merge conflicts in Git? To handle merge conflicts in Git, the below steps are followed. Identifying the conflict. When you try to merge branches, Git will alert you to any conflicts. You will see messages indicating which files are affected. Open the conflicted files. Open the files that have conflicts. Git marks the conflicting sections, showing the differences between your branch and the branch you are merging. Resolve the conflict. Edit the file to manually resolve the conflict by choosing which changes to keep or combining both the changes. Remove the conflict markers once you are done. Stage the changes. After resolving the conflicts, stage the changes using git add filename command. Complete the merge. Finally complete the merge with git commit. You can also add a message explaining the resolution if needed. Then test. Always test your code to ensure everything works as expected after resolving the conflicts. Question number 6 is, what is CI/CD and why is it important? CI/CD stands for Continuous Integration and Continuous Deployment or Continuous Delivery. It's a set of practices that help developers deliver code changes more frequently and reliably. Continuous integration involves automatically testing and merging code changes into a shared repository. Developers submit their code regularly, and automated tests ensure that new changes don't break the existing functionality. Continuous deployment extends CI by automatically deploying tested code to production. It means that every change that passes the test can be released to users quickly and reliably. Importance of CI/CD. Faster releases. CI/CD allows teams to release new features and fixes quickly, improving responsiveness to user needs. Second is higher quality. Automated testing helps catch bugs early, leading to more stable software. Third is reduced manual work. Automation minimizes repetitive tasks, freeing up developers to focus on more valuable work. The last one is improved collaboration. CI/CD encourages collaboration among team members as everyone works with the same codebase and integrates their changes regularly. The next question is, how do you implement a CI/CD pipeline? To implement a CI/CD pipeline, we follow the following steps. Choose a CI/CD tool. Select a tool that fits your needs, such as Jenkins, GitLab CI, Circle CI, or GitHub Actions. Second is setting up the version control. Use Git or another version control system to manage your code. Ensure your code is hosted on a platform like GitHub or GitLab. Third is define your pipeline. Create a configuration file that outlines the stages of your pipeline, such as build stage, test stage, and deploy stage. Build stage is compiling the code and installing the dependencies. Test is running the automated tests to check the bugs. Deploying is automatically deploying the code to a staging or production environment. Fourth step is configuring triggers. Set up triggers to run the pipeline automatically on events such as code commits or pull requests. Then, monitor and iterating. Monitor the pipeline for failures and performances. Use feedback to improve the process continuously. The last step is integrating notifications. Add notifications such as Slack or email to alert the team of pipeline results and any issues. In summary, implementing a CI/CD pipeline involves choosing a tool, defining your stages, automating the workflow, and continuously monitoring and improving the process to ensure fast and reliable software delivery. The next question is, explain the role of Jenkins in CI/CD. Jenkins is a powerful open source automation server that plays a key role in CI/CD by helping teams automate their software development processes. Here is how it works. Automates builds. Jenkins automatically compiles code and runs the tests whenever developers commit changes to the repository. This ensures that code integrates smoothly and catches issues early. Second is pipeline support. Jenkins allows you to define complex workflows through pipelines, enabling you to specify stages like build, test, deploy in a clear and repeatable way. Third is Jenkins is extensible. With a wide range of plugins, Jenkins can integrate with various tools and services such as cloud providers, testing frameworks, and notification systems, making it highly adaptable to different workflows. Fourth is continuous deployment. After passing tests, Jenkins can automatically deploy applications to staging or production environment, ensuring quick delivery of updates to users. Fifth is monitoring and reporting. Jenkins provides insights into build status, test results, and deployment history, helping teams monitor their processes and make informed decisions. In summary, Jenkins is a vital tool in the CI/CD pipeline that automates builds, tests, and deployments, enhancing collaboration and speeding up software delivery. Question number 9 is, what is build trigger and how does it work? A build trigger is a mechanism that automatically starts a build process in a CI/CD pipeline based on specific events. Now, how it works? First is it is event based. Build triggers are activated by events such as a code commit, pull request, or schedule time. Second is automatic initiation. When the specified event occurs, the build trigger signals the CI/CD tool to start the build process. This can include compiling code, running tests, or packaging the application. Third is immediate feedback. By automatically initiating builds on changes, developers receive quick feedback on their code, helping to catch issues early and improve collaboration. In summary, build triggers streamline the development process by automating the initiation of builds based on specific events, ensuring that code changes are continuously tested and integrated. Question number 10 is describe a blue-green deployment strategy. A blue-green deployment strategy involves maintaining two identical environments. One is green and one is blue. One is current application version and the other is the newer version. Whenever a new update is released, it is first deployed to the blue environment while green environment is still running and serving the users. Once the new version is tested in the blue environment to make sure everything works fine, the traffic is switched to the green environment. The question is, what is infrastructure as a code? The answer is, infrastructure as a code is a way to manage and set up your computer systems and networks using code instead of doing it manually. Here is how it works. Code instead of manual setup. Instead of clicking buttons in a user interface to create servers or databases, you write the code that describes what you need. Then automation. This code can automatically create and configure all the resources you need, like servers, networks, and storage, without manual intervention. Then comes version control. Just like you can track changes in software code, you can track changes to your infrastructure code. This means you can see who made the changes, why they were made, and easily revert back if something goes wrong. Then comes consistency. Because you are using code, you can create the same environment every time, reducing errors and making it easier to replicate setups for different projects or teams. Then comes speed. Infrastructure as a code allows you to set up environments much faster than manual processes, which is especially useful in modern development practices like DevOps. The next question is, how do you use Terraform to provision infrastructure? To use Terraform to provision infrastructure, the below steps are followed. Installing Terraform. First, Terraform is downloaded and installed on the computer. Then, write the configuration files. Create a file where you describe the infrastructure you want. For example, you might specify servers, databases, or networking components using a simple language that Terraform understands. Third is initializing the Terraform. Run the command terraform init in your terminal. This sets up your project and downloads any necessary provider plugins that allow Terraform to interact with cloud services like Azure or AWS. Then plan the changes. Use the command terraform plan to see what Terraform will do. This shows you a preview of the resources that will be created, updated, or destroyed, helping you catch any mistakes before making changes. Then applying the configuration. When you are ready, run terraform apply. This command will actually create the resources based on your configuration file. Terraform will communicate with the cloud provider to set everything up. Then manage the changes. If you need to update your infrastructure later, just modify the configuration file and repeat the plan and apply steps. Terraform will take care of updating only what's necessary. Then destroy the resources. If you want to remove everything you have created, you can run terraform destroy and Terraform will clean up all the resources. The next question is, explain the concept of idempotency in the configuration management. Idempotency in configuration management means that you can apply the same set of changes multiple times without causing unintended effects. Here is how to understand it simply. Consistent results. When you run a configuration management tool like Ansible, Puppet, or Chef, if the system is already in the desired state, running the configuration again won't change anything. It will simply confirm that everything is already set up correctly. Then safety in reapplying. This is important because it allows you to run your configuration scripts safely, even if you are not sure whether they have been applied before. You can confidently reapply them without worrying about the breaking anything. For example, imagine you want to ensure that a specific software package is installed on a server. If you run the command to install it and if it's already there, an idempotent system won't try to install it again. It will just check and move on. If it's not installed, then only it will try to install it. Then easier management. Idempotency helps with managing infrastructure because you can automate processes more easily. You don't have to keep track of what's been applied. You just run your configurations and they will bring They will always bring the system to the right state. In short, it ensures applying the same configuration repeatedly won't leading to any errors or changes beyond what's intended, making it a key concept in reliable DevOps practices. The next question is, what are the advantages of using Ansible over other configuration management tools? Using Ansible has several advantages compared to other configuration management tools. It is easy to learn. Ansible uses YAML file for its configuration files, which is simple and easy to read. This makes it accessible for beginners. The second point is no agents required. Ansible operates without installing agents on the managed servers. It uses SSH for communication, which simplifies setup and reduces resource usage. Then no central servers needed. You don't need a central management server. You can run Ansible commands from any machine with access, allowing for more flexibility. The last is idempotent. Ansible is idempotent, meaning you can run the same playbook multiple times and it will only make the changes if the system is not already in the desired state. This reduces the risk of errors. The next point is rich library of modules. Ansible comes with many inbuilt modules that allow you to manage various systems and services easily, saving you from writing custom scripts. Then comes strong community and support. Ansible has a large community providing plenty of resources, modules, and documentation which can help you troubleshoot and learn. Then it's good integration. It works well with the cloud providers, container tools, and other software, making it a versatile choice for different environments. The last is declarative language. You can define what you want your system to look like rather than how to achieve it, making your configurations clearer and easier to manage. The last question is, how do you manage state in Terraform? In Terraform, state management is done through a state file that keeps track of the resources created. Here is how it works. State file. When you run Terraform apply, Terraform creates a file that stores the current state of your infrastructure, including details about all the resources. Tracking changes. This state file allows Terraform to know what resources exist and their configurations, making it easier to plan and apply future changes. Remote state. You can store the state file remotely in AWS S3 or Terraform Cloud to enable collaboration among team members and to keep it safe from local machine issues. Consistent updates. When you make changes and apply them, Terraform compares the current state in the file with the desired state in your configuration files, ensuring that only necessary updates are made.